Morning, Heather. So what we're going to do is we're going to take a look here at part A. So find the approximations to the original function at point 1. Okay, so that's what this guy is asking us. Okay, so the idea is this: we have some unknown function. Let me go ahead and draw that out for you. Okay. So even though in this particular problem, they give us the function. This piece right here would be unknown. Okay, so all that we really know over here is we know what the initial condition is. So we know that that y at time 0 is going to be 1, and we're given that y prime, the derivative, is equal to negative 8y, like that. Okay. Now, so again, this piece here in the red, that's unknown. So we're going to use that later. Well, actually, we're going to use that for part B. Excuse me. So here's the thing. I'm going to go up here to a height of 1. So here's 0. Okay. I know that my original function, so again, the axes, this is time. This is the y. This is the y axis. Okay. So what I've got here is that at time 0, I'm up here at a height of 1. Just like that. Okay, now the question is how can I, at time 0.1, how can I estimate this height value? So what I want to know is what is y at 0.1? So what is its height value? This is the guy I'm trying to estimate. So what I'm going to do is I'm going to use the idea of the slope at this point right here. Okay. And I'm going to use that to estimate the function value here. So it's like this. If the function, let's say my function looked something like this. Okay. And I had a point here. Now let's say I want to estimate this point, the height value of this point right here. What I could do is I could take the slope right here, the tangent line slope, and I could use this point, the point on the tangent line, to estimate this guy right here. Okay? So that's what we're going to do. So I've got this guy. Now the question is, what's the slope at this guy? So the slope is given by this equation. So the slope at 0 is given by negative 8 times the y value. Now, probably a better way of writing this is just to say it's y of t. So it is y of 0. Let me write that out for you. Just like that. So this is negative 8 times the y value is 0. And the y value at 0 we know is 1. So what that tells us is that the slope, I'll do it here in green, the slope of the tangent line here, that slope is negative 8. Okay, that's the slope coming right here. Now I don't know what the actual function looks like. I just know what the slope is. Again, it's similar to if I had a curve that looked like this, and I grabbed this guy right here. What I know is the slope. I don't know the actual function line, just the slope. Okay. So what I'm going to do now is I'm going to say, well, let's extend this down, and let's go over to point 1. Okay. So if the slope is negative 8, and I'm traveling 0.1 over, okay, the next point that for my estimated point is going to be negative 8 times 0.1. So again, what I'm going to do here, let me draw this out just a little bit better. Slope here is negative 8, and if I extend this, and I need it to be, whoops, let's put that back in there. Okay, so here's -8, and if I extend this guy straight, okay, what I'm going to use is this point right here as an estimate for the actual function. Now we know the actual function is this guy right here, but usually that's not given to us, okay? So what we're trying to do is we're trying to estimate the actual height, which is probably maybe somewhere here, using this line. So what we do is we know the slope to get down to here, okay? We can do this out algebraically if we want to. We can say that the slope is the change in the y value over the change in the x value. So what we'll do is we'll take that change in y value over the change in x value, multiply it by the change in the x, and that'll tell us what the change in the y is. So what we're going to do is we're going to take the slope here is -8. We'll take that -8 and we're going to multiply it by 0.1, and that'll give us -0.8. And so what that tells us is that we went down by -0.8, we went over by 0.1. So now notice that if I take -0.8 and divide it by -0.1, divide it by 0.1, positive 0.1, if I take the change in the y divided by the change in the x, I get the slope, which is exactly, so I'm basically working backward, right? Okay, so I found this point. This point over here, the estimate for that point is at a height value of 1, take away 0.8, so it's at a height of 0.2. So, given a change in t value of 0.1, which is just one of these guys, okay, I'm estimating that y at 0.1, so y at 0.1 is approximately equal to 0.2. The height value of 0.1 is approximately 0.2. So now what we'll do, I know your question was on these guys down here, and so I'll get to those, okay, but I want to set this up, okay. So now let's go ahead and erase all that, and let's go with a different change in t value, okay. So again, we're trying to estimate y at 0.1, okay, and what we have, did I erase that? Oh no, I didn't write it down. So our first estimate, right here, I'll put it in up here. Our first estimate is if we change t just by 0.1 and we're only going out to 0.1, then our estimate was 0.2, just like that. Thanks, Mai. Okay, so now what? Well, now we're going to change our t value by 0.05. So what I'm going to do is I want to subdivide this thing up with a change value of 0.05. Well, 0.05 falls in there twice. So this goes out to 0.05. So this length right here is 0.05. This length right here is also 0.05. Okay? And so my change in t value, t, on this axis changed each time by 0.05. That's what this guy right here means. Okay? So let me get rid of that so that we've got a little bit more room to work. So what we're going to do now is we're going to take the slope here, but instead of going all the way to here, we're going to use this slope to go to right here, and then we're going to take the slope here and use it to get over to here. So why would we do that? Well, look, let's say my function is curved like this, which it actually is, okay? And let's say we started out here, and we wanted to get an estimate for this guy in the purple. Well, what we would do is the first attempt was to take this slope right here and get an estimate. Okay, but this right here is the error amount. Our second attempt is going to be to divide this so that we use the green line to only go to here. And then once we're here at this guy, we're going to use its slope, the slope field, to go to here. Notice now that this is our new estimate, whereas this was our old estimate, and our new estimate is closer. So by putting more subdivisions in there, we're going to get closer and closer to the this actual value right here. So how are we going to do that? Well, what we're going to do is we're going to take that negative 8, the slope here, but we're only going to go out to 0.05. So the question is, how far down do we go? Well, that's pretty easy to calculate. So I'm going to erase this now. So what I'm going to do is I'm going to take the slope here, multiply it by the change in x, and that'll tell me the change in y. So we'll multiply it by 0.05, just like that. And so what we'll get is this here, negative 8 times 0.05, I think is negative 0.4. Yeah, so negative 0.4. So what it tells me is that if I extend this line down, the height value is going to be, so I'm going down by negative 0.4. So this value, the height value right here, is going to be positive 0.6. So I'll go ahead and I'll put that in there right now. Okay, so I had to pause my video here, and I came back about 2 hours later, so I can't remember exactly where I was, but I believe I was saying, let's see here, I gotta get my board back up. So I believe what I was saying is that we have a situation up here in this upper portion where we're going to estimate the height of this guy, right, by using this slope. So what we did was we said the slope was negative 8. We had to go over by 0.05, so the drop down was negative 4, so we get this 0.6. Now what we're going to do here at this spot is we're again going to find the slope. Well, the slope changes, and the slope changes by this equation. So it's no longer negative 8 here. The slope is going to be something different. So what we're going to do is we're going to take the y value, okay, at 0.05. So the new slope, the slope here that's going to be used to estimate the height over here, this new slope is given by this equation. So the slope at 0.05 is equal to negative 8 times the y value at 0.05. Okay. Well, the y value at 0.05 is estimated by 0.6. So this would be negative 8 times 0.6, which is going to be negative 0.48. So what that tells us is that this is the slope. The slope of this guy right here is negative 0.48. Excuse me, negative 4.8. I said that wrong. Okay, so negative 4.8. Now we're going to use that guy to estimate this. What we do is we take the length over, which is 0.05, we multiply it, okay, by this guy, so 0.05, we'll multiply it by negative 4.8, and we'll get a drop down value here of negative 0.24. So if we come down, oops, sorry about that. If we come down by 0.24, that'll be 0.6 minus 0.24. And so that'll give me 0.36. So this guy is 0.36 for his estimate value. You can see that the old estimate value of 0.2 is down here. The new estimate value is 0.36, And probably the true value is somewhere up here. Okay, so we're going to get closer. We're going to keep inching our way closer to that. Now, if it's not quite clear where this negative 2.4 came from, let me just explain that. You've got your new y value. Okay, your new y value. If our slope, the slope here, was negative 4.8, the slope is the change in the y over the change in the x. So the question is, what is the change in the y? So we have change in y over change in x is equal to negative 4.8. We know the change in the x, so the change in the y is equal to negative 4.8 times the change in the x. So what I'm doing is I took this guy, multiplied by the change in x to get my change in my y value right there. So what we'll do is I'll do one more with you because I don't think we need to go through all these. So let's go ahead and take a look at this guy. So what we're going to do, same drawing. Here's 0.1 on my t. This is y of t. We're starting out at a height of 1. But now we're changing our t value by 0.025. So if we change these by 0.025, this guy's 0.025, this guy is 0.05, and this guy's 0.075. Okay, so each of these, the change in t is 0.025. 0.025, 0.025, 0.025. Okay, so now what I'm going to do is I'm going to find the slope right here. Now we already know the slope is negative 8. Again, where did that come from? Well, we took our equation here and we took the y value at 0, which was 1, and we multiplied it by negative 8. So this guy right here has a slope of negative 8. Now we're going to use it to get over to this point. And so we're going to use that slope. Sorry, this is really a straight line. Let me draw it as a different color. We're going to use it to get to this point right here. So we're going to use this as an estimate to get to here. Well, what do? We take the change in the x value, we multiply it by the slope, so negative 8. So to get to this point right here, what we're going to do is we're going to figure out how far down we have to go. Well, we know that this is 0.025. We know the slope is negative 8. If we multiply those together, we get a distance down of negative 0.2. So this length right here is negative 0.2, which gives me a height value here of 0.6. Excuse me, 0.8. Because I was at a height of 1, I'm going down 0.2, so this would be 0.8. So now what I'm going to do with this guy is I'm going to use its slope. Let's do that in yellow. So its slope to get over to here. Well, the slope here is given by negative 8 times the y value. Well, the y value is 0.8. So it'll be negative 8 times 0.8, or negative 6.4. So what we're going to do is we're going to take negative 6.4, and we're going to multiply it by the distance over, and that'll give us the distance down. So take that by 0.025, so we're going to multiply this by 0.025, and that gives us negative 1.6. So this length right here is 0.16. So if this is down by 0.16 and we were at a height of 0.8, oops, man, let me grab my calculator here. So we were at a height of 0.8, we have to subtract 0.16, we're now at a height of 0.64. So this guy right here is at a height of 0.64. Now what we're going to do again is we're going to use the tangent line slope to get over to here. So the slope here is going to be equal to negative 8 times the height. Well, the height is 0.64. So 0.64 times negative 8 is negative 5.12. So that's the slope. We take the slope and multiply it by the change of x, which is 0.025, and we're going to get a decrease value. This value right here is negative 0.128. So we got to go down by 0.128. So we'll take 0.64 and subtract 0.128, and that'll give us a height value here of 0.512. So again, I took my height value, 0.64, and I subtracted 0.128, and it ends up being 0.512. Then what we'll do, we got one more, we'll take this slope and use it to get to right here. Well, the slope here is 0.512 times negative 8, which gives us a slope of negative 4.096. Multiply that by the change in the x value, which is 0.025, and we're going to get, so negative 4.096 times 0.025 gives me a drop down value of negative negative 0.1024. So we'll subtract that from this, and we'll get a height value of 0.4096. Okay, and so on this next one, instead of doing this 1, 2, 3, 4 times, we're going to have to do it 8 times. Okay, and then of course you're going to do the same thing with a length not out to 0.1, but a length out to 0.2. So hopefully that explains where these values here are coming from. Now, the next question is going to ask you, so I'll just kind of quickly cover the next question. The next question asks you, using the exact solution, compute the errors. So each of these are approximations to the exact value, which is given by this equation. So y at point 1, the actual height of the graph at point 1 is right here. This is an approximation. This is the actual value, and it's given by this equation. So we go e negative 8, not 0.8, negative 8 times 0.1. So that's e to the negative 0.8. This gives us a value. Whatever that value is, that is the exact solution. And we want to see how far does it differ from each one of these. And that's going to be the next table.